sensors. Sensor, also called transducer, is a device which converts one form of energy into another form, such as a microphone which converts sound into an electrical form, or a light sensor, which senses the light and gives output according to intensity of light. So, we can say that sensor is a device that detects and responds to some type of input from the physical environment, such as light, heat, motion, moisture, pressure, and used to switch voltages or currents. Basically, sensor can be classified into two categories, such as analog sensor and digital sensor. We will learn both, one by one. First is analog sensor. Analog sensors produce a continuous output signal, which is generally proportional to the quantity being measured. Physical quantities such as temperature, speed, pressure and displacement are all analog quantities. For example, the temperature of a liquid can be measured using a thermometer or thermocouple, which continuously responds to temperature changes as the liquid is heated up or cooled down. Next type of sensor is digital sensor. Digital sensors produce a discrete output signal or voltage, that is a digital representation of the quantity being measured. Digital sensors produce a binary output signal, in the form of logic 1 or logic 0. Now, as the disc rotates with the speed of the shaft, each slot passes by the sensor, in turn producing an output pulse, representing logic 1 or logic 0 level. Now, these pulses are sent to a register of counter, and finally to an output display, to show the speed or revolutions of the shaft. Humanoid robots correct its position without stopping, based on information obtained from its sensors. Such types of sensor are ground sensor, visual sensor and ultrasonic sensor. Next is light detecting sensor. It detects the intensity of light and gives the output according to it. Light detecting sensor is used in homes or offices for security purpose. It can also be used in automatic street light system. The light sensor is a passive devices that convert light energy, whether visible or in the infrared parts of the spectrum, into an electrical signal output. Now, let's see types of light sensors. It can be grouped into three main categories, that are photoconductive cells, photovoltaic cells and photojunction devices. First let's see photoconductive cells. These photo devices vary their electrical resistance when subjected to light. Photoconductivity results from light hitting a semiconductor material, which controls the current flow through it. Now, photovoltaic cells. These photo devices generate an EMF in proportion to the radiant light energy received, and are similar in effect to photoconductivity. The most common photovoltaic material is selenium, used in solar cells. Next is photojunction devices. These photo devices are mainly true semiconductor devices, such as photodiode or phototransistor, which use light to control the flow of electrons and holes across their p-n junction. Photoresistors are semiconductor devices that uses light energy to control the flow of electrons, and hence the current flowing through them. The commonly used photoconductive cell is called the light-dependent resistor, or LDR. The light-dependent resistor is made from a piece of exposed semiconductor material, such as cadmium sulfide. A photoresistor is made of a high-resistance semiconductor. If light falling on the device is of high enough frequency, then photons absorbed by the semiconductor give bound electrons enough energy to jump into the conduction band. LDR changes its electrical resistance from several thousand ohms in the dark to only a few hundred ohms when light falls upon it, by creating whole electron pairs in the material. The most common type of photovoltaic light sensor is the solar cell. Solar cells convert light energy directly into DC electrical energy, in the form of a voltage or current, to a resistive load, such as a light, battery or motor. As we see in animation, photovoltaic cells are made from single crystal silicon p-n junctions, the same as photodiodes with a very large light-sensitive region, but are used without the reverse bias. When illuminated, the light energy causes electrons to flow through the p-n junction, and an individual solar cell can generate an open circuit voltage of about 0.58 volt. Solar cells have a positive and negative side, just like a battery. Next type of sensor is temperature sensor. A temperature sensor is a device that gathers data concerning the temperature from a source, and converts it to a form that can be understood by electronic components. The most commonly used temperature sensor is LM35 temperature sensor. The LM35 series are precision integrated circuit temperature sensors, whose output voltage is linearly proportional to the Celsius temperature. LM35 temperature sensor is a 3-terminal device. When we increase the temperature, output of the sensor also increases. Next, we will discuss about application of temperature sensor. LM35 sensor used to detect temperature rise in the environment, such as a device which detects high temperature and give the information by buzzer. These types of system is used for security purpose. LM35 sensor is also used to detect a temperature and display it into the display devices, such as LCD and 7 segments. Next type of sensor is gas sensor. In current technology scenario, monitoring of gases produced is very important. From home appliances, such as air conditioners to electric chimneys and safety systems at industries, so monitoring of gases is very crucial. Gas sensors are very important part of such systems. Now, construction of gas sensor. The sensor module consists of a steel exoskeleton, under which a sensing element is housed. This sensing element is subjected to current through connecting leads. This current is known as heating current through it. Gas sensor module has a steel mesh, copper clamping ring and connecting leads. The top part is a stainless steel mesh, which take care of filtering out the suspended particles. Now, the pins are placed on a bakelite base, which is a good insulator and provides firm gripping to the connecting leads of the sensor. Here, the hexapod structure is constituted by the sensing element and 6 connecting legs that extend beyond the bakelite base. Now, the hollow sensing element, which is made up from aluminium oxide-based ceramic, has a coating of tin oxide. Using a ceramic substrate increases the heating efficiency, and tin oxide being sensitive towards absorbing desired gas. Here, leads responsible for output signals are connected using platinum wires, which convey small changes in the current that passes through the sensing element. Gas sensor has 6 leads, 4 of the 6 leads, A and B, are for signal fetching, while 2, represented by H, are used to provide sufficient heat to the sensing element. Next is working of gas sensor. Gas sensor used in smoke alarm circuit, absorb gas molecules. Change the resistance of the tin dioxide layer. This changes the current flowing through the sensing element, and is conveyed through the output leads. The output of gas sensor is analog in nature, so we have to use analog to digital converter or op-amp, to convert analog signal into digital form, for further processing. Next type of sensor is ultrasonic sensor. Ultrasonic sensors are devices that use electrical mechanical energy transformation to measure distance from the sensor to the target object. This sensor consists of 4 pins that are VCC connect to 5V DC, trigger pulse input that triggers the sensor. Echo indicates the reception of echo from the target and ground. An ultrasonic sensor consists of a transmitter and receiver, which are available as separate units, or embedded together as single unit. Now, we will discuss working of ultrasonic sensor in 6 steps. Step 1. Make trigger pin of the sensor high for 10 microseconds. This initiates a sensor cycle. Step 2. 8 into 40 kHz pulses will be sent from the transmitting piezo transducer of the sensor, after which time the echo pin on the sensor will go from low to high, as we see in animation. Now, step 3. The 40 kHz sound wave will bounce off the nearest object and return to the sensor. Step 4. When the sensor detects the reflected sound wave, the echo pin will go low again, as we see in animation. Next is step 5. The distance between the sensor and the detected object can be calculated based on the length of time the echo pin is high. In the last step, if no object is detected, the echo pin will stay high for 38 milliseconds, and then go low. Next, we are going to discuss about application of ultrasonic sensor. Ultrasonic sensors is used in obstacle avoiding robot. If an object is in the front of the robot, then it take decision and turns. In this robot, ultrasonic sensor sense the objects. Next application of ultrasonic sensor is for automatic car parking system. Here, in automatic car parking system, sensor calculates the distance or direction of an object, from the time it takes for a sound wave to travel to the target and back, and gives the instruction to car where to park. In humanoid robot, ultrasonic sensors are used to detect obstacles, including glass, that the visual sensor cannot detect. Next type of sensor is position sensor. The most commonly used of all the position sensors is the potentiometer, because it is an inexpensive and easy to use position sensor. Here is the construction of potentiometer as shown in animation. It is a wiper contact, linked to a mechanical shaft, that can be either angular or linear in its movement, and its resistance is proportional to position. Another type of position sensor is rotary encoder. Rotary encoders are non-contact optical devices, used for converting the angular position of a rotating shaft into an analog or digital data code. In other words, they convert mechanical movement into an electrical signal. There are two basic types of rotary optical encoders, that is incremental encoders and absolute position encoders. First we will discuss about incremental encoder. An incremental encoder is an electromechanical device, used to provide feedback signals for motion control applications. A common application of an incremental encoder is to indicate the position of a rotary or linear mechanism. As the disc rotates, pulses from the emitter strike the sensor every time. A slot on the disc is aligned between the emitter and the sensor. Each pulse of light is converted to an electric pulse by a signal conditioner. If the slots are 1 degree apart, the encoder will produce 360 pulses each time it makes a revolution. If the encoder turns 30 degrees, the counter will show 30 to indicate the corresponding position. Next type of rotary encoder is absolute position encoders. Absolute position encoders are more complex than quadrature encoders. They provide a unique output code for every single position of rotation, indicating both position and direction. Absolute encoder has 4 concentric tracks that vary in size to form sections with unique 4-bit code patterns to represent 16 positions. Each 4-bit number represents a sector of equal size. Absolute encoders are used in applications when the devices being measured are inactive for a long period of time. These encoders are also used when power to equipment is turned on and off frequently, such as telescope and grounds. Thank you for watching us.
Melihat film masih metode untuk teori mikro. Operasi tentang teori